Hello everyone, welcome to Vigyan Bharat. Today I'll be going to discuss a problem which was uploaded on 7th of April. So let's start with the problem. What we are given, a square matrix, a 4 by 4 square matrix such that both A and its adjoint are non-null, that is, they are not null matrices. Further, it is given that if their determinant is 0, then we have to find the rank of the matrix A. So to solve the problem, I have used some abbreviations which should be clearly understood before moving ahead. Here Mij denotes a sum matrix of A obtained by deleting the ith row and jth column. Determinant of Mij is basically the minor of the element Aij, again which we obtained by deleting or hiding the ith row and jth column. And finally, capital of Aij denotes the cofactor matrix of this capital Aij here denotes the cofactor corresponding to the element small aij. And this abbreviation is basically a shorthand for our new series in which we are going to discuss the problems every alternate day. So let's begin with the problem. Let's first note down the given information so that we can draw some important conclusions from them. What we are given, a matrix A of 4 by 4 order. This is given to us. Further, it is given that A and adjoint of A are non-null. We know what is a null matrix, so non-null basically means they are not the zero matrices. That is, A is not equals to the zero matrix and adjoint of A is also not equal to the zero matrix. Fine. Now we are also given that determinant of A is 0. What we are given, that determinant of A is 0. If we remember, we know identity combining these three from our elementary classes, that A into adjoint of A equals determinant of A times the identity matrix of order n, where A is a matrix of order n and n is adjoint of A is also an n square matrix. So this is general identity that we know. Now in particular, for our A 4 by 4 matrix and adjoint of A and the determinant value which is given to us 0, so this equation becomes A into adjoint of A equals 0 scalar times the 4 by 4 identity matrix. So this is same as the 4 by 4 identity matrix. So we have 0 everywhere. So this is the right hand side. Fine. So this we have now A times adjoint of A equals to the 0 matrix. So this, let me call it 1. This information is given to us. Further, it is given that since both A and adjoint of A are non-null and the determinant of A is 0, since A is a 4 by 4 matrix and it is given that determinant of A is 0, so from here we can conclude that the rank of the matrix A certainly has to be less than 4, because we know in general that rank, if A is an n square matrix or n cross n matrix, then rank of A is n if and only if A is invertible, that is its determinant is non-zero. But what we are given that its determinant is 0, so we have that rank of A has to be less than 4. So let me denote this by suppose say 2. Now this we have. Further, it's also given that A is a non-zero matrix. A matrix, sorry, not determinant, A. The matrix is non-zero, so this certainly implies that rank of A is at least 1. Rank of A is at least 1, because if a matrix, the rank of A would have been 0 if and only if A is a zero matrix, but it is a non-zero matrix, so it forces that rank of A has to be at least greater than equal to 1. Okay, so let me call this 3. Now what we are given, that A times adjoint of A is a zero matrix, where both in equation 1 again A and adjoint of A are both equal to the zero matrix, but both are not equal to, they both are non-zero matrices. So since now adjoint of A is a non-zero matrix, if we recall the definition of adjoint of A is basically the transpose of the cofactor matrix of A, or if I denote Cij to be the matrix of cofactors, entries basically corresponding to the cofactor values of the cofactors corresponding to the element Aij. Cij denotes value of cofactor, corresponding to the element Aij. Then adjoint of A is this transpose, this T denotes the transpose of this matrix. This is the matrix of cofactors. Now this is given to be non-zero to us, and here each entry Cij, if you recall, suppose I choose my particular value C11, so by definition the Cij is -1 to the power I plus j, suppose I and j are 1 here, times Mij. This is in general. Cij is -1 to the power I plus j of Mij, where Mij denotes the minor, which we obtained by hiding the ith row and jth column. So C11 would be -1 to the power 1 plus 1 times M11, and so on. You can calculate Cij for different values of I and j. But what is important to us, that since this matrix is non-zero, so certainly there is some non-zero element present in this matrix, the matrix of cofactors. And in particular, if suppose let me say C11 is the non-zero element, then C11, how we will going to find C11 using M11. And what is M11 now? What we have to do, basically we're going to hide the first row and first column of the matrix A, and then calculate its determinant. Calculate the determinant of the new 3 by 3 submatrix. The 3 by 3 sub matrix which you obtained by hiding the first row and first column, then the determinant of that will be the value of this M11, and finally inserting it here, you will going to find the C11. So what you observe here, from here we have made if you observe something, that what you found that M11 is non-zero. You find a minor of order 3, which is non-zero, and in general we know that the rank of any matrix, rank of any matrix A equals to the order of the largest non-zero minor present. So from here, now the observation which we have concluded, that we have a 3 by 3 minor which is non-zero, and from above we know that since the rank of the matrix has to be strictly less than 4, there exists a non-zero minor of order 3. So by the result which we have discussed, that rank of matrix is same as the order of the largest non-zero minor present. So the rank of the matrix A has to be 3 in this case, which also satisfies this inequality, that is rank of this matrix is strictly less than 4, and of course it is greater than or equal to 1. So we have solved this problem, that in our case rank is 3. So I hope you got a clarity behind the reasoning, how we approach to the solution. If you have any doubts in any steps, then please do drop a comment, and join our Telegram group. There we post such problems, also on our Facebook page, and subscribe the channel if you haven't done till now, and press the bell icon for receiving the notifications at the earliest, and we'll meet again in a similar problem, in a similar video. So thank you so much for watching.